Hi, everybody. Welcome to the next slot of Flow conference. And we have a special guest tonight, a guest from far away who woke up so early today to be with us. It's Andres Sacco from Argentina. Hi, Sacco. How are you doing? Hi, Andres.
Hi, Ivan. Thanks. Yes, it's too early in the morning here in Argentina, but I wake up so early to have this conference and this particular talk.
Okay.
So
Yeah, great. Well, Andres is a practicing software engineer. He writes in a number of languages, and also he participates as a tech reviewer of the books of a well-known publishers such as Manning, Pact, and Epress. I think most of you are reading these books, and maybe some of these books had contributions from Andres as well. And today's talk is about microservices. Well, microservices is a sort of hype technology. So all the companies now they want to like do microservices now, and we know good parts about microservices. But today we are going to talk about difficult parts, right?
yeah, most of the developers start using microservices like a silver bullet about solve all the problems, but it's not the silver bullet. The problems come after some time, perhaps weeks, months, or years. The problems start to appear, and you say, "Oh, this is not the best decision that I took it." But
Yeah.
yes,
Okay. I have to tell that this session will be pre-recorded, is pre-recorded, so we will watch the recording. But please don't hesitate to ask any questions on Telegram chat. Me and Andres will monitor Telegram chat, and we will answer your questions right after the video or in discussion zone. So please don't hesitate to do this. And also, please don't hesitate to give your feedback. You have buttons to press, whether you like it, whether you don't like it. Please explain what you like, what you don't like, so that next time Andres will do better and will bring better presentation, and our program committee as well. Okay, I think it's time to start, right? So let's play the video.
hi, and welcome to this conference about microservices dealing with the changes. The microservices appeared many years ago as the solution of many of the problems that the previous systems have it. During this talk, you will see that these microservices introduce another problems, and I will show you different strategies to solve or reduce the risk that something happen on production. But first, let me introduce me. My name is Andres Sacco. I am a Java developer most of my time, but also I develop on other languages like Kotlin, Scala, PHP, Node.js, and also others which are not so popular like Haskell. Also, I participate as technical reviewer on Pack, Airpress, and Maining, and on the books or the different products that this editorial have it. Also, I wrote some books. Some of them appear on the screen. I record some courses and I create different theoretical practical projects with the idea that show a real problem to the readers and give some clues to find the correct solution. Also, I participate as a speaker on different conferences on Latin America and Europe. And if you have any doubts after this talk, just contact me on using my LinkedIn or my email, and I will try to help you as soon as possible. Let's do a recap about these microservices. One of the first advantages is that you have small components. In the previous architecture, you have a big component that have all the entire logic of your platform. Now you have split on different components. Each of them have one responsibility. So there are other advantages that you have more component, more small component. One of them are that you can use different languages or different frameworks, or different version of the same language. This is an advantage because if I have a component that is too old and use, for example, an old version of Java, and I want to create a new component that uses the latest version of Java, I can do it because are not connected. It's not a restriction. And also, if I want to develop a component using another language, I don't know, Go, Rust, Scala, whatever that you want, is not a restriction. Other advantage is high cohesion. For high cohesion is all the components, all the things that are inside of one microservices have the same meaning. For example, I can create a component or a microservices which are have the responsibility of contain all the information of the catalog of the cities, countries, or airports. And I can have another component that, for example, is in charge or responsible for do all the pricing of, I don't know, one product, include the markup, or check if this product have a discount or whatever. This is the high cohesion. Imagine that if you have a card, all the components inside a card are connected in some way with a card. It's impossible that you open your card and find, I don't know, the engine of a plane. That makes sense. This is the cohesion on one microservices. You optimize the resources because if you need, for example, that more number of requests on one of the components, you can scale just one of part of the system, and the other part could be have the same number of instances of the same number of servers. So you optimize, you increase or decrease the number of instances of your application depending on the number of requests. So in some way, you can have control about the bill that you receive at the end of the month. You can do an upgrade or migration from one language to another because it's connected with the first point. That is a small component that don't have any kind of relationship. Of course, have the relationship that I send you a request and you give me a response. But inside of the microservices, you can use whatever that you want. So if you want to migrate to another language, if you want to do an upgrade, you can do it without any problem. And you have less time to deploy. Small component take less time to deploy it. If you have a big component that access to many databases, to many components with a huge number of lines of code, takes more time to deploy to production. So in some way, if you have a mistake or introduce some bug on production, if you want to do a rollback, it's simple because it takes less time than if you have a big component. Let's go to the disadvantage because everything is not okay. You increase the complexity because you have the same logic split in different small components. So perhaps it's difficult to follow the flow or how one component connects with another one. You have distributed transactions. Imagine that in the previous architecture, you have one big component that insert on different tables of the database. Now you have different components. Each of them have one responsibility. So imagine that the one of the components fail, the others need to detect the fail or deception and do a rollback. So this is a complexity, an additional complexity. You have more logs because you have a lot of applications, so you need to check many things, and you have more instances of each application. So in some way, it's difficult to debugging. You need to understand the entire architecture of your system to detect a possible problem. in the previous architecture of the idea of monoliths, you have in one place everything, so you can start your application and put some point of debugging and detect the problem. But when everything is distributed on many components, you need to pay attention about the request and the response and how the different microservices connect. Well, everything looks fine. The problems are okay. It's not a problem, a real problem for now. But at some point, you need to start to introduce modifications about the behavior of these microservices. You need to add or remove attributes on the request and the response of the different endpoints that your different microservices have it. You need to change the behavior of this endpoint. This is not connected with add or remove attribute. You need to do something new inside of this endpoint. I don't know, add some validation or remove some block of code, whatever that you want, but it's not connected with add or remove attribute on the request and the response. Or you want to deprecate some certain logic or an endpoint that is not most useful because have a lot of bugs and you create something new. I don't know, many reasons to deprecate an endpoint. And you want to modify certain configuration like the user and the password of a database or this kind of modification that always happen. And the last point is a big number of requests between microservices. You create a new microservices and you have a lot of requests that these microservices receive. These kind of things are just the most relevant, but are a lot of this problem and a lot of possible solutions. And at the end of this talk, I will show you some books that will help you to find a possible solution to most of the problems. Let's start with modify a request and a response. I have an existing point that suffered some kind of changes on the structure. Before the endpoint introduced the modification, I have just a name, a code, and is enabled or not. Is the response of an endpoint that I pass the code of one country and return all the information. And for some reason, I want that give me the translation of this country on different languages, like Spanish, English, Portuguese, and others. So I changed the structure like this, and you say me, okay, this is okay. If I don't pay attention on this translation or my microservices don't use this translation, for me, it's not a problem. What is the difference between the previous response? Well, there are some problems with this. If you change the structure of the request and the response, imagine that your request, your endpoint need to pass an extra parameters. Perhaps if the endpoint don't receive, could return an exception. This is a possible problem. The other problem that is other microservices can parse this new attribute. There are some frameworks and some languages that have the ability to say, okay, if I don't have an attribute to map with this new attribute, I will ignore it. I will don't take in consideration, so nothing happened. But there are other ones that say, okay, if you send me something that I don't have on my class, on my domain, I will throw an exception because something changes. And it's not correct that I process. So it's a problem. And imply modification in many places. The idea of have an architecture of microservices is one microservices can be used for many, not just for one. So if I change something in one of my endpoints, I need to take in consideration that I need to communicate with many teams or many microservices and say, okay, something will change. and I need to coordinate with multiple teams. And this is the most difficult part, because we need to deploy on production the changes at the same time to reduce the risk that something happen on production. Okay, well, which could be a solution? Create a new endpoint. If the changes are a lot and change a lot of things on the request and the response, the best alternative, because reduce the time that something happen and you can deploy something without risk, is create a new endpoint. And the idea is the microservices B have two versions of the same endpoint with different names, of course. And you create it and you need to communicate with the other teams and coordinate that, okay, you need to migrate for the old endpoint to the new one, and the new one have new attributes. If you want, you can use it, the old one, but at some point I will deprecate it. And what are the benefits of this approach? First one, that I earn time. With the other approach, if I introduce the change and deploy on production, something could happen on the different environments. So if I create a new endpoint that anyone use it, nothing happen. I earn time just to all the teams coordinate and migrate to the new one. I reduce the risk to deploy on production something that could break the entire platform. And of course, I have more logic because I have two endpoints that could do the same. This is one of the possible solutions. There are other ones. Let's move to another problem. Change the behavior. As I mentioned, the change on the behavior not imply change the request and the response. It change something inside the endpoint or the microservices, like add validation. Imagine that I have an endpoint which receives some kind of information and persists directly to the database without any validation. So at some point I decide, okay, I need to add some validation. I change the behavior at this point of the endpoint, because do something, and if the attribute or the request is incorrect, perhaps the endpoint throw me an exception. I can add some mechanism of cache. If I access many times to the same endpoint, perhaps I want to add some mechanism of cache to reduce the number of requests and the response, and reduce the latency, the time that you takes the request to give me a response for the other endpoint. I want to try to do an A/B testing. Imagine that you have two versions of a query that access to the database, and I want to check with a real number of users, with the real traffic of my platform, which of them is the best alternative. Another problem could be I access to some database or some endpoint and I need to change the URL or change something. These are change of behavior. Also, I remove some kind of logic. Imagine that I need to deprecate some part of the endpoint that is not necessary, or I move it to another place. And finally, I want to improve the performance. And most of the time, improve the performance implies that you change a lot of things in one part of your application. All of these things are change of behavior. Now, what happened with these changes? If you develop and do all the changes on your application or your microservices and deploy to production, if something not work, this implies that you need to do a rollback, and you miss a lot of time to do it, because I deploy to production, I take some time to collect metrics and to collect the error and detect that something is not normal, and I need to do a rollback. So all this time, it's a huge number of minutes that you spend with the new version of the application. Produce some certain number of problems which you could detect or not, because you deploy all the changes together. This is a problem. And you show all the changes for all the users. You don't have the chance to say, okay, 1% or 10% or I don't know, the user of my company just show you the new feature, and for the rest appear the previous version of the application without any changes. To solve this, there are a pattern which is mentioned on the Martin Fowler papers many years ago, which is feature flags. Feature flags appears with the idea to change dynamically the behavior. And to change dynamically imply that you can have metrics about this kind of problem that appear. But why this is dynamic? Because imply that you introduce little modification on your source code that, like an if-else condition, is like, okay, if this value this feature is enabled, I will use the new behavior. If not, I will continue use the previous one. And you have some kind of mechanism to turn on or turn off these new features. And you can have metrics about this. Of course, you can have metrics depends of the framework and the language that you use. Not all the languages and not all the frameworks have this kind of metrics. But most of them have a good number of metrics that show you that how many of the users use the new one and how many use the previous one, the number of errors, and all of this information that is necessary to take the decision, okay, I want to use the new one or the old one. It's simple to implement, as I mentioned, because it's an if-else condition, and most of the framework and plug and play, and you need to indicate in some part of the code which are the features that you want to test. And you can show these changes just to a certain number of users, a percentage. You imagine that you say, okay, I want to check if the query, the new query to the database works fine or not. I want to check with 10% of my user. So 10% of my user go directly to the new query and the rest from the previous one. And if everything works fine, if I want to increment, I can increment directly on the console of the tool. I don't know, 50%, 80%, 100%, and without need to redeploy the application, because it's just change the value on the tool, and the application will detect the changes and change the behavior. And it's agnostic to the language, because you can implement it on different languages. Of course, perhaps on Java or Kotlin or Scala or this kind of language, there are many libraries that have a good documentation, metrics, support, and many problems solve it. And in another one, don't exist many libraries or support, but it's dependent language. The idea is show you that the problem exists, and this is the possible solution. The next problem is I want to change the configuration of my application. Many times you want to change something in your application, and this change implies a redeploy of your application. These kind of things could be a connection with the database. You change from one database to another one. You change many things, like the cron, the time, the period of the execution of a cron. A cron is a job that run in a period of time. One time in a day. All the days at 2 p.m. These kind of things. And do something. Like send emails, for example. The change to the URL to another microservices could be another thing that you want to change. Imagine that you develop some application and you deploy to production. For some reason, you do a mistake and put the wrong URL and you detect this on production and say, oh, I need to roll back my entire my application to the previous version and deploy again. And this could be a huge problem. So you need to find a way that solve this problem. Also could be that the username and the password of some microservices or some services like the database or the, I don't know, S3 of the FTP changes, and you need to do a modification. All these changes imply a redeploy of the application. So how could be the process of this change, the configuration? First one, you need to find the place that you need to introduce the changes. Second, you need to write the changes on your source code. After that, you create a merge request, which implies that someone needs to check if the modifications are okay or not before to deploy on production. This is the next step, is validate the changes. And the last one, and the most important, is deploy the changes on production. Imagine that this process takes time. And if you need to do this many times in a week, in a year, you lost a lot of time. So you need to find a solution to this kind of problem. A possible solution is find a way that you reload the configuration files. So if I enter inside of the server and change the configuration, the application needs to detect these changes and say, okay, something is changed, and I will need to use the new version. Imagine the connection of URL of a database or the user and the password of a database. This is depend of the framework and the languages. There are some languages that detect the changes and reload the application. And there are other ones, like, for example, Spring Boot with Java, that when you start the application, the framework takes the value of the configuration, and if you change something inside the server, the application doesn't detect these changes and not reload. So you need to find another solution to this. You need to have in some place this configuration file. Is not an option that I have an environment variable on each of my servers, because if I change something, I miss the previous value. So I need to version in the changes. So if I version in all the changes, there are possible solutions like Spring Cloud Config, which detect that the new version of the configuration appears and inform to the microservices to do a reload. Say, okay, there are a new version of this file, please reload. And the application reload without any intervention of a user. So it's automatically. Of course, there are other solutions, but this could be the most simple and easy to implement. Another problem, you need to deprecate endpoint. As you remember, the first problem that we tackled is, okay, I need to introduce changes on my endpoint. And at some point, these changes imply that I create a new endpoint. But exists the previous one and the new one. And at some moment of the life of the microservices, I need to say, okay, this endpoint needs to disappear because it's not possible to maintain two endpoints. So deprecate an endpoint could imply that deprecate an endpoint or the entire microservices. So in this case, in the case of the picture, I create a new version of my microservices D. And the idea is that most of the other microservices, A, B, and C, start to migrate from one microservices to another one. The main problem with this is I need to communicate with all the teams. But let's explain the process of deprecation. First one, you need to create the new microservices or endpoint. After that, you, as a possible solution to reduce the risk to communicate with all the teams and with all the external team and detect a problem on your microservices or endpoint, the best alternative is, okay, my team have this new endpoint, these new microservices, and have some internal consumer. So the best alternative is migrate the communication from these internal microservices or the microservices that my team is responsible, and check if everything works fine. If everything works fine, the next step is communicate with all the external consumer and explain that something changes, that a new endpoint appeared or a new microservices appear and they need to deprecate, need to migrate from one endpoint to another one or one API to another one. And the last part, which is the most important, is you need to deprecate the endpoint or microservices. When you create the first step, when you create the new endpoint and or microservices, you need to declare or create or define which is the deprecation time of this endpoint. 1 month, 1 year, 6 months, whatever that you want, but you need to say, okay, at this date, this endpoint will disappear, or I will remove the code, or I will stop the microservices. Which are the main problems that could happen with this? You have more chance to have bugs, because if you have two versions of the same API or two versions of the same endpoint, you have more chance. Imagine that you discovered that one of the endpoints or one of the microservices have a bug, and you have the same problem in the other one, in the previous one, in the old. But the solution is not compatible because you change a lot of things, you do a refactor, you change the language, right? Or change the framework. So you need to introduce a lot of modification to solve this problem. But the problem is the same. Another problem implies more resources. You have two servers running the same source, not the same source code, but the same solution. Or imagine that you have a catalog and microservices that show you or return all information in a catalog. You have two versions of the same catalog running at the same time. You spend more money to the same logic if the other teams take time to do the migration from one place to another. And multiple things to maintain is connected with the first thing that I mentioned. If you use different languages, using different frameworks, you pay attention to solve the problem in one language and create a solution for the other one. So you spend more time to do the same things. Another alternative, which could be the best, is create a gateway. The idea of gateway is hide behind some kind of box, which is the real implementation or a real endpoint that the other microservices use. As you see, you have the microservices A, B, and C that pass through the gateway. And the gateway decides which of the microservices will we use. So the other components don't detect or don't know which is the real implementation that they use. So at some point, I can deprecate the microservices D, and all the other components, microservices A, B, and C, will use the new version. This could be useful if you start to do a migration or you will create a platform, because it takes less time, because any of these microservices connect directly with these microservices D and B, D and version D. If you have an entire platform that have a lot of microservices, perhaps create a new gateway that solves this problem could be not the best option because takes time. You need to communicate with all the teams to explain the idea of use this gateway. This is the deprecation process. The last problem is the number of requests that an endpoint or microservices receive. Imagine that for some reason you have the information about the catalog of the cities and the airport distributed on many places, and you detect that have many inconsistencies about the name of a city or the code of country or a currency. So you decide at some point, say, okay, I want to create a new microservices which consolidate all this information in one place, and one team is responsible for maintaining the information. So now this is the scenario. I have one microservices which is communicate with many others. Why this solution that solve a problem that the inconsistencies introduce a new problem? Well, could introduce the latency because you need to go to another microservices to obtain the same information. And if these microservices, then our catalog microservices, have a big number of requests, could we take more time to return the response? So the entire platform increase the latency. Imagine that you enter in an e-commerce and find a product, and in a normal situation takes 2 seconds to give me a result. Imagine that you enter in the same e-commerce in the Black Friday or Cyber Monday or this big event that many people enter in the same place. Perhaps the site takes 10 seconds. But these problems are connected that many other microservices try to access the same information, which is static, not changed frequently. Imagine that the name of the cities or the countries or the airport perhaps change one time in a year or in 5 years. It's not that something that change all the time or many times in the day. With the latency, you can lose money because if you take more time to give a response to the user, if the user don't have a result or take more time, perhaps the client or the user say, okay, I will go to another site to buy my product, and you lose money. Could affect some part of the platform or the entire platform, depend on the criticality of the information and depend how many other microservices use the same microservice, connect with the same microservices, and imply that you have a big number of resources because you need, okay, I have a problem with my microservices, with my catalog. I need to have more instance, more memory, more CPU to these microservices to solve all the, or to return all the requests, which are, a possible solution could be add some mechanism of cache. The cache is like not accessed directly to the microservices. In some point, you have some information on some place without the idea, the access to directly to the microservices. There are many times or many different types of the cache. One of them is in memory. Inside of our microservices, you store the response. Imagine I want the information about one city, and I save for a period of time this information on the memory of one of my instance of my microservices. If you have 10 instances, just one of them have this information inside the memory. You have the alternative to have distribute on many places, save this information in a database like Redis. So all the microservices connect with this database to obtain the information and return it. Or you can have the mechanism of cache proxy or in front, which is in front of the microservices. So the microservices A try to communicate with the microservices B, but in fact, the microservices A communicate with some mechanism of cache which check if the value exists or not in the memory, and if exists, return the value. If not, communicate directly with the microservices, with the catalog, obtain information and save in memory. But for you, it's transparent. You don't detect if you communicate directly with the microservices or with the cache. You need to take in consideration also the duration of this value, the frequency of the changes. As I mentioned, it's not the same save the information about a country or a city and save the information about the conversion rate or the blockchain currencies. The relevance of this information is not the same, say, the country information, or, for example, the markup of a product. If I have some microservices that have the markup of all the products in my site. And the last part, which is so important, is the number of elements that you save it. It's not the same that you have in memory, I don't know, 100 rows which have 1 KB in memory, which is nothing. And imagine that you have you want to save a piece of information that takes 1 megabyte of memory. It's not the same. And also you need to take in consideration the hit radio. The hit radio is, okay, someone do a search or find this information about some city, which is the possibility that someone else do the same search to obtain the same information. All these things you need to consider to say, okay, I want to use this mechanism or this one. And depends of the mechanism that you want to use is you spend less or more money, but your platform is stable. There are some companies that introduce this mechanism to reduce the problems on your platform, like Mercado Libre, Almundo, and TravelX. With this solution, solve the problem that the platform could suffer, that many users access to the same information at the same time, and also reduce the traffic between the different applications, which imply, depend of your cloud provider, that you will increase or decrease. Last, best practices. Try to visualize the entire picture, not just, okay, I want to change something on these microservices and I don't pay attention to the entire platform. You need to take in consideration all the components that interact with these microservices and how these changes will impact on the other part of the platform. Try to have a good communication with all the teams about your plans. Imagine that you don't communicate that you will deploy a new version of the same endpoint and without, I don't know, 10 attributes, or you add 10 attributes. Something could happen. You need to communicate and test everything with other teams before to deploy on production. Try to do the changes in a way that are backward compatibility. So these changes reduce the risk that if I deploy something, the entire platform is unstable or appear a lot of problems. And last, try to roll out the changes, not for all the users. Try to reduce the number of users that have the possibility to see the changes. So in that way, you can see if the changes work fine or not. And in the case that something is wrong, you can do the rollback and return to the previous state. Lastly, one of the most important things, the future readings. There are many books like Microservices Pattern, Monoliths to Microservices, Building with Microservices, and Fundamentals of Software Architecture that explain how to solve this problem and many more. The idea is that if you have time, try to check some of them, because not explain directly with the use of some particular language is not okay. Microservice pattern is all related with Java, and the implementation is with Java or with Rust, with Scala. The idea is that the authors explain the concept, explain the solution in a practical way, and in a way that is not necessary that you start to write code. It's like, okay, I have this problem, I can solve it with this solution. My team can find the implementation of this pattern of this technology. And also, I follow these two blogs, which have many solutions of the most common problems. The developer to architecture is one of the best, because in a short video of 5 minutes, explain the context of a problem and in a theoretical way, and show you different alternatives of solution depending on the context of your company. This is a good way because you don't have one alternative, you have many alternatives, and you can decide which of them is the best for your company or for your current situation. And last, it's time to the question. So if you have any doubts, please show me the...
Oh, thank you for cool presentation, Anders. Actually, we have lots of questions, a number of questions on Telegram chat, but unfortunately we ran out of time, so we have to move to discussion zone. But I'd like to ask you one very short question. You suggested 4 books in your presentation. I realized that I never read any one of them. What to start? From what book to start, from your point of view?
I think the best one is Microservices pattern, because show you an overview about all the possible problems and all the possible solutions that you have it in the microservices. The most common, you have a lot of problems, but the most common appear on that book.
Okay, cool. Microservices patterns. All right. Thank you very much for your presentation again. Those who are watching us online, please stay with us in discussion zone. It will start shortly. And others, bye-bye.
Bye-bye.